there's this cool little equation. It's called the Newton's law of cooling or Newton's law of warming. And what it says is it says that some number times the temperature difference between whatever you have and its environment, so the temperature of the thing you have and its environment, is going to equal some rate, right? And so this is what's known as a differential equation, but it's a separable differential equation. So I'll go through a couple of steps. I'm not going to spend a lot of time on it, but then I thought it'd be kind of fun to see what does it mean and could we predict the temperature on something. So if we go through, we separate this out and we get that, let's see here, if I use my little thing here, we get that dt over this, t minus t environment equals k d, and then this is t for time, right? And so this is just two integrals, which is much nicer to do. So this here becomes the natural log of t minus t environment, we'll call it ENV, like that, equals k, and then this is time, right? So now we can plug in a couple of numbers that we can measure and know, and then that'll give us a formula that we should be able to figure out what the temperature should be for any length of time. So I know right now outside the temperature is 35 degrees Fahrenheit. So this is the environment. I also know that the vehicle, when I shut it off, the temperature of the coolant was 190 degrees Fahrenheit. So this is the temperature at time 0. So temperature at time 0 was 190. So if I want to rewrite this to try to get temperature, right, then, well, okay, I do E, so this becomes T minus, in this case, now it's going to be 35 equals E to the KT, and then, I'm sorry, this is plus C, right, plus E to some constant. So we'll call that C1. And then actually we're going to wrap this all in here. So this is going to become C2 E to the KT equals T minus 35. Okay, so we need to know what C2 is, and we need to know what this K is. So, okay, so at time 0, right, so at T equals to 0, right, that becomes E to the 0, so that just becomes 1. This whole thing is 190 minus 35 equals C2 times 1, right? So now I can just add the 35 across. So we get 190 equals C2 plus 35. Actually, we didn't even have to do that. This is just 155 equals C2, right? So 155 equals C2. So now we can just plug that back in up here. So we're going to get T minus 35 equals 155 E to the KT. So we need one other piece of data to get where we're going. And so I went out at 138 minutes and saw that the temperature was 108. So 108 degrees Fahrenheit equals T at 138. So we can plug that in here and we can see that 108 equals 155 E to the KT. This T up here is now times 138, and then plus 35. Okay? So all we have to do now is figure out this thing. So, okay, so we're going to say, okay, 108 minus 35 equals 155. So we're going to 155 go away. This is E to the KT. Yeah, that's 138. How do we get rid of that? we make this a natural log. So that gets rid of this guy here. And then we put all of that over 138. And so now this is going to get us our K, right? So if we do that, we get the number of this K. So we're going to put that here. K equals negative 0.00545627. And it kind of goes on. So what can we do with this? Well, now that we have that, we can go in and we can figure out what the temperature should be right now. So I've got a timer going. It's been 3 hours and 51 minutes. Probably by the time we get out there, we'll say it's been, we'll put it right at 4 hours. We'll say it's been 4 hours. So we want to know, what is the temperature going to be when we go out there? So we can write the equation. We can say T will equal 155 E times negative 0.00545627 times 240 minutes, and then all of that plus 35. So if we do this, use a calculator here. We get that it should be just about 77 degrees Fahrenheit. So let's write that down. Say that this is going to be 77 degrees Fahrenheit. So we can go out and check it. Now, is the temperature still 35 degrees outside? I'm not sure. It may have cooled off a little bit, so the temperature might be a little under that. But it should be right around there. It's definitely not going to be 110, and it's not going to be 30. So we'll try this out and see what we get. Okay, well, it's a little over just about 4 hours and 4 minutes. So let's see what we get here. So we'll just turn on that. And sometimes we have to, we're not starting the vehicle, I have to cycle that. All right, let's see. So it says 31 degrees out, and let's try this, see if we get anything. Come on, focus. So 78 degrees. So I'd say that worked pretty well. And something that's important to note too is this will only measure in 2 degree increments. So it'll measure 76 or 80. So our guess looks pretty good. And here again you can see 31 degrees out.